Over the break, I filled in all the probabilities for all the different branches, but let's talk about them here. So it wants to know what's the probability for each one of these branches. Now, we had figured out 96 out of 100, 95 out of 99. But if you picked a non-defective one for your first pick, then there's still 4 defective ones left out of a batch of 99 now, because you've already got one that you've already chosen to inspect. Okay. But what if you picked a defective one first? There's a 4 out of 100 chance of picking defective first. And that brings this one. But then there's only 3 defectives left. So it would be 3 out of 99 for another defective one, or 96 out of 99 for a non-defective, because you picked a defective one first. There are 96 good ones left in the batch. And I chose to write it up this way. NN for non-defective, non-defective. ND for not defective, and then a defective one. DN for a defective one first, and then a non-defective one. And DD for defective, defective. Just like with algebra, I mean, there's an order to this. So I'm assuming that one's on the left or first and one's on the right or second. Okay, so now let's look at the question they're asking here. Oops. All right, it wants to know what's the probability that one dishwasher will be defective. Okay, so what they're really asking is what's the probability of one dishwasher defective? So either DN or ND. It's kind of weird, but because they say one, not at least one, you're assuming an exactly one. So equals probability exactly one defective. Right? That's what they're really asking. Okay, so it's going to be tricky, but we're going to have to find each one separately. So we're going to find the probability of N, it's going to be DN, DN, and then we're going to add to it the probability of, we're not going to print, that was my bad, probability of ND. Now notice those are disjoint, right? Can't have DN and ND at the same time. So this is going to be an addition rule, right? The OR makes an addition rule. There's no point in trying to subtract away something that's both DN and ND, because that's impossible. So this is just the addition rule for disjoint events. Okay, so what's the probability of defective then non-defective? All right, so the probability of defective was first, let's go back to the picture. Defective first is 4 out of 100, then non-defective is 96 out of 99. So let me push this up for a second. Hey. It's one of my least favorite features about the new Windows. I know Macs do it, but it drives me nuts. All right, so 4 out of 100 times 96 out of 99. So that's the probability of getting a defective one first, then a non-defective one. Then I'm going to add to that. Okay, now I want a non-defective one first. So that's over at the top over here. Oh, see? Stupid. Everybody wants to be more like a Mac, not me. Although Macs are better, but that's a whole other discussion. All right, so I want this one. Oh my gosh. Stop it. Thank you. All right, you're just going to have to trust me. It's 96 out of 100 times 4 out of 99. Okay, so I'm going to have to find each of those separately, and then I'll add them up. Actually, to be honest with you, you could do it all in Excel, but I'll do it right now. So I want the probability, so 4 out of 100 times, what was it, 96 out of 99. That's one of them. And then I want 96 out of 100 times 4 out of 99. And here's a hint, they're going to be the same because they have the same numerators, just switched, and the same denominators, right? And then you want to add them up, so sum those two equals the sum of those two, and it gives you 0.077. All right, so that's 0.077776. That's the probability of one defective, no more, no less. Okay, so now what about the probability that at least one, see those words? At least one is defective. Okay, so that's going to be this. You want the probability of at least one defective. You want the probability of DN, ND, or DD. And that's 1 minus the probability of none, and that I found with Excel. And it's there. All right, I'll pick up right here next time.